Hello everyone, today we are going to look on demonstration of experiment 2, that is projectile motion. At the end of this video, students should be able to determine the acceleration due to gravity g using projectile motion. Projectile motion is a form of motion experienced by an object or particle that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. In order for the ball to fly off during projectile motion at the edge of the table, we need to release the ball from a certain height h on the curved railing. As the ball is placed at a certain height h, it has gravitational potential energy mgh. As the ball rolls, the gravitational potential energy is converted to translational kinetic energy half mv squared and rotational kinetic energy 1/5 mv squared as shown by following equation. At the end of the track, the ball will leave the edge of the table with an initial horizontal velocity v. The ball will fly off and undergoes projectile motion. The landing point of the ball from the edge of the table r is given by r equals to vt. You will substitute equation 2.4 into equation 2.3 and we will obtain equation 2.5 as shown, where t is the time taken for the steel ball from the end of the curved track to reach the ground. This equation will be used in this experiment to determine the value of gravitational acceleration g from projectile motion. The apparatus required for this experiment are a curved railing, a meter rule, a cell phone tape, a scissors, a steel ball, a pendulum bob and a string, a plasticine, 2 pieces of carbon paper and 2 pieces of A3 paper. Now let's set up the apparatus. Place the track on the table whereby the end of the track must be exactly at the edge of the table and horizontal. Attach the string and the pendulum bob at the end of the track. Measure the height h from the edge of the railing to the landing surface. Release the ball from the highest position of the curved track to estimate the landing point. Put the carbon paper facing up the A3 paper on the estimation area. All this must be pasted on the floor using cellophane tape. Measure and set the height h to release the ball on the curved railing. Release the steel ball from that height and determine the position of landing point. Measure the distance between the landing point and the pendulum bob. Record the measurement as range R. Repeat the experiment twice for the same 7 different heights and then calculate the average value for range R. So the next thing you have to do is to tabulate your data. You have to repeat the procedure for 7 different value height. You may pause the video to copy and complete the table. Plot the graph of h against r squared. From there, you will determine the gradient of the graph. And compare the equation of 2.5 with linear equation. In comparison of h will be equals to y, r squared will be equals to x, and 7/10 gt squared will be equals to m. Therefore, your gradient of the graph is equals to 7/10 gt squared. So, the acceleration due to gravity in your experiment will be g equals to 7/10 mt squared. Where do you get the mt squared? By referring to the graph of h against t squared from freeform motion, you will obtain the value of t squared for h using extrapolation. For this purpose, the maximum scale of y-axis in your h versus t squared graph must be around 90 cm. Hi students, so the next thing you have to do is write a full report. So you have to compare the value of g that you have obtained from this experiment with the standard value. State any source of error as well as any precaution taken to overcome them. Lastly, don't forget to write your conclusion for this experiment. That's all for this time. Thank you for watching.